In this video we're going to have a look at making assemblies and sub-assemblies, cleaning up the timeline with having minimal features by using sub-assemblies, and creating drawings utilizing the AS 1100 standard, and also looking at how to do drawings for welding. Alright, so let's get started with this one. I'll just turn off this motion study. So this is an assembly of a 6-jaw robot end effector, or like a 6-finger gripper. And as you can see on the timeline here, we've only got about 12 or so features making up this assembly, which is ideal for optimizing the computer. Start creating large assemblies, then the computer can really start to chug. I'll put some links in the description, but Wintergarten with his Marble Machine X, he's done a really good video that I watched before doing this one, showing how to do sub-assemblies, and yeah, there's some great tips in there that I learnt from him. I don't want to rehash everything, this is a much different model, so at least that's different. But if you look at where I'm at with this one, most models you'll start off with sketches, and then from there you can loft or revolve, or normally would probably be extrude, and that's what we're doing in this case. So a couple of sketches, extrude, and yeah, the fillets, and there we go. So at about this point here we should be converting this body, or probably all the bodies, once we've got the fillets and things that we want, convert them to components. So we'll convert this to a component, create a component from body as an example. So we've got this component here. Now what we can do is, once we've got our sub-assembly, which for this one I basically created the finger and 4 of these parallelogram little arms, letting it move. I'll show that in a minute, but you want to get each one of these components out into its own design. So we'll export that and save to this project. So I could start a new project, so I'll use this one. And to get to that point you have to make sure you've got your component how you want it. So that's the timeline does not come across with that once you put your component in there. However, you can update your component in that file and then put it into the sub-assembly, and that will carry over. Component 10. Let's have a look at that. Alright, there it is. So it's just exactly how it was. Now basically you'd bring across all your other components into, you just add them into a sub-assembly. So for example, I've got one here, I can add this, insert into current design, and that's another point to show here, is that it actually comes in the same relative position to the origin and the other components as where it was from the design that you made it in. But that's okay, you don't have to keep it there, and actually we'll just cancel that off, and I'll show that in this sub-assembly here that I've made. Yeah, so for this sub-assembly we've just got one of the fingers, and then when I've brought in all the sub-assemblies into the main assembly, I've offset them each one by 60 and then 120 degrees and 180 degrees, so they've filled up all the angles of the 60 degree, the 6 different fingers on the main base there. Okay, so I'm going to try and go through this fairly quickly. It might be a bit over your head if you're new to Fusion, but we'll carry on. So adding the joints here, I'll put some more links in the description to some good videos for doing joints and other useful resources, kind of like a compilation of a few different things in one. So it's just, I think it'd be a bit too long and boring to really cover off in detail each individual thing, but I'll sort of take it for granted that you understand joints. Anyway, so I've added the top 4 joints there, and then the bottom 4, I'll just take a couple of steps back here so you can see. Now what I've actually had to do here is, I'll go back a couple more. You can see I've added in these pins for this bottom hinge, and the reason for that is that the bottom, I can't do joints here without having some sort of a component to do a joint as a base, and I want to do joints now so that when I copy all these sub-assemblies into the main assembly, all the joints are there ready to go. You'll see a bit more in a minute why that is the case. So I've gone ahead and done that. I've got my joints there. Now, the other thing, I'll mention it now, is you need to limit the joint's movement in the sub-assembly. When the joint goes across to the main assembly, for some reason, I don't know why, you can't adjust the joint's limit of movement. It's just some weird thing, but you know, it's okay. In the sub-assembly you can adjust it, and then it'll carry over to, I'll show you now. Edit joint limits. I believe this was the joint that I was editing. Yep, so we'll take that to 45, say OK, and I think you have to save for it to sort of update properly. Now, if we go to our assembly, close this off. Now you should be able to see that these need, that needs updating. So in the tree here you can see all these exclamations. Now there's only one assembly that's changed, so that's only going to update one thing, but get all latest, that'll fix it all. And they should all switch over to 45 degrees. Yep, so now they're all 45. And yeah, so that change has come through. The other thing to mention here is this feature here. I've made a rigid body. This is what I was talking about back before in the sub-assembly. So I extruded out those pins and made components so that I could join the like the base of those sub-assemblies to this main assembly. I guess you call it the main base, whatever you want to refer to that as. So yeah, that allowed me to basically make the main assembly, and then still have those joints come through. So this feature is 1, 2, 3, 4, 5. So each one of these joins the link that joins the joint from one finger to the next. So this is going from joint in finger 5 to finger 6, and then the point of that is so that when you move one of the joints, it's not too bad, it's pretty smooth. Yeah, they all move. So that's what we're looking for in this model. That's not necessarily what you might have in the end device, but just as an example here, I thought it'd be pretty cool to make all the fingers move together. And yeah, so there you go. So that's assemblies and sub-assemblies. I've sort of skipped through that pretty quickly. Yeah, now what we'll do here is I'm just going to quickly talk about the AS1100 drawings. So I want to say thanks to Aaron from the DCT channel. He was pretty helpful in giving me some guidance. I did a bit of research, and he pointed me in the right direction as well. So thanks, Aaron. The nicest way that I've found to do this is you have your component in the data table here, and then new drawing from design. And this will lead me to my next point about getting the component in the orientation that you want it to be in for the drawing. Yeah, see how this is, it's a bit skew, so just cancel that. Right, so what I want to do here is turn the origin on, do a sketch, and just create a square on the origin. Doesn't matter. Basically, we just want a flat surface to align our body to there, and then we can get it in the orientation we want. Joint. So this definitely gets it into the position you want. I guess that's the main point. Nope. Try again. Okay, close enough. Now, remove this body. And remove and delete do different things, just depends what you want. I think delete actually affects the timeline more, whereas remove allows you to retain the things that were affected by it in the timeline, but still remove the body from the file, so, or the component. Now, if we save that, I know this is a bit long-winded, but it's it is sort of significant to doing drawings. It's the less exciting, more professional skills. So what do we got? Insert new drawing. Now regarding the AS1100, alright, so yeah, another tip courtesy of Aaron was standard changed to ISO. Units, I mean that's probably going to be millimeters for me. So we can override, we want third angle, that's important. Alright, in this quick example here, we've got the right side and the top view or projection, and now I'm going to do a projected view of the front. And then if you wanted to, depending on the client and the usage of the document, you could add an extra view there. I believe that's technically not AS1100, but in my opinion that would be pretty useful. So yeah, to have that more three-dimensional perspective. Anyway, I'll leave that there for now. And then symbols and dimensions. So obviously you want to add dimensions so you can see what's going on, and that's quite nice and easy to do. Just keep clicking on things that you need to add. Yep. So anyway, that's a quick example. And then of course we've got symbols, so datum and feature controls. So yeah, I won't go into that for now, but to add tolerances and things, that's obviously a lot more detail, and yeah, maybe we'll get into that in a future video. So the other thing that you need, AS1100, yeah, you'd put that somewhere in the table down here, and this is all nice and easy to edit. Just type things in here. So yeah, there you go, that's your drawings. When I was looking for resources for the topics covered in this video, I found a few good ones here that I'll share. So this is the Winter Garden Assemblies. He's got a good tutorial, so I'll put a link for that one in there. That's actually, yeah, it's really nicely done. It's a simple example, but he really explains it nicely. And Lars Christensen has a good video here. This one was quite helpful as well, so I'll put a link for that. It's quite a long video actually, but it really it's good. Yeah, I watched it all the way through and it's good. And of course NYC CNC has a lot of Fusion 360 tutorials, and this one on joints I found was quite useful as well, so I'll put a link for that. Then yeah, I just sort of found this small page here, and this is a nice little introduction to the AS1100 third angle orthogonal projection. Yeah, what is third angle orthogonal drawing? So yeah, it's got a little video there as well, and a hand done sketch. And I'm not sure about copyright with this one, but archive.org has actually got a copy of the AS1100 on here. It's a bit of a weird thing that the standards are actually a book. I mean, I guess someone has to write it, and there is a copyright issue there, so that's fair enough. But yeah, you actually have to pay to get that. And yeah, so then Aaron suggested buying this engineering drawing handbook, so I'll put a link to this one. Final topic I want to cover in this video is welding in Fusion 360 and in drawings. And so I don't have a whole bunch to say about it really, other than check out this thread on the Autodesk forum, and I found there's a lot of images on here and useful information. Basically the takeaway for this is have the parts that are going to the material that's going to be welded together should be separate bodies, and then the welds should be separate bodies, and then in the drawings have the welds and the way the welds are post-treated all documented in the drawings. And yeah, it's basically as simple as that. So yeah, I'll add a link to this thread in the description as well. Alright, we'll leave it there for this video. Thanks for watching. I hope you found it useful, and I'll just leave you with a few images of the 3D print of the hex gripper, or the 6-finger robot end effector. I think it turned out pretty cool. It's a nice little piece, it's fun to play with, and in future I might end up adding a servo or some sort of motor to it to actuate it. And yeah, I'm looking forward to adding more robots to the workshop actually, so that'll be a cool usage future project to add that on. So yeah, if you want to see more videos and see what I'm up to in the future, then please consider subscribing, and I'll catch you in the next video. Cheers, bye.